Hello, welcome to this video. We designed this video to deal with the topic that we put there, calculate mole from a given mass. And then from there we will go to the next skill, which is after we have obtained the numbers of mole of a certain mass, we want to calculate how much was the volume of a gas that was produced according to that number of mole. Okay, so let's hop on and let's begin. Okay, so there are basically two background informations and skills that we need to acquire so that we can deal with this. At the end of this video, I have picked one of the questions from a past paper from IGCSE. Okay, so part one of the basic information, we're going to deal with calculate mole from a given mass. Let's move on. Okay, so in order to acquire this skill, it is quite simple and straightforward. Well, I have stated there for all our attention, there is only one formula when it is given a mass to you. Okay, it was given a mass, for example, 5 grams of sodium hydroxide. I was given to you 0.75 gram of magnesium. Okay, it was given to you some kind of chemical in the measurement of mass, and usually in the numbers of, in the units of gram. Okay, if you were given this and you want to find mole, so what you will do? Okay, so this is the formula that you want to keep this in your permanent memory, which will prove so beneficial to you. Well, this, here you go, mole equals the mass divided by AR or MR. Now I have also written down there what is AR and what is MR. This is just in case of any one of us who doesn't know what are they. Okay, I put out there AR, which is actually the short form for relative atomic mass. And where can we find this information? Well, you can just go to the periodic table and read directly from them. Let us go to find one periodic table. Okay, so this is the periodic table that is attached at the back of your exam paper. And if you look at the key of how periodic table is labeled or contain the information, this is the part that you want to pay attention to, relative atomic mass. So the AR is stated down at below the atomic symbol. So let us just go to see the one that is nearest to it. Okay, for magnesium, what is the AR of magnesium? 24, alright, 24. So when we put in the gram, so it becomes 24 gram, which means 1 mole of magnesium chemical carries the mass of 24 gram. And if you go and take a look at others, for example, chlorine, if you look at the number below the symbol, which is the relative atomic mass, meaning 1 mole of chlorine, it has 1 mole of chlorine atom, okay, it has 35.5 gram. So that is called relative atomic mass. Okay, so you know where to find this. Okay, then what is MR? MR stands for relative molecular mass. And can you find that? Yes, you can. How? Just add up the relative atomic mass of all the elements in that molecule or in that compound. Okay, so we will not go very details into explaining all of them. That is for another time. Okay, but however, in the process of the examples, we will do that together, and some brief explanation will be provided for you. Okay, so in short, all that you need to know is mole equals mass over AR or MR. One more time, let's revise that. mole equals to mass divided by AR or MR. Okay, so in that way, you can easily find the mole. With the assurance, mass will be given to you in the questions, and AR will be given to you in periodic table, and the MR can be calculated easily by you by adding up all the relative atomic mass of each element. Got it? Okay, so we have gone through that, and I just put it down here just in case some of you hear the word like molar mass. Okay, molar mass. Yes, it's actually the same meaning. The only thing that we put in here, this just simply means the same meaning as molar mass, which is the mass of an element or a molecule or a compound. 1 mole of that compound or that element carries this much of gram. Okay, so you still easily come back to this formula, mass over AR or MR. Alright, so we have seen where to find the relative atomic mass. So I'm going to put here for our reference, just in case we need that as we go through the examples. Okay, so you may also see this at the back of your exam paper. So it is advisable each time you do your revision, you will have this copy handy for you to refer to. Okay, and now we give practice 1. Calculate the number of moles of 9.2 gram of sodium. Okay, the first thing, do you see the, oops, sorry. Okay, here's the mass was given to you, 9.2 gram. Okay, then you know that what is the substance you're talking about? Sodium. And of course, it will be super handy of being familiar with the symbol. Of course, in this case, it was provided for you. Okay, so now let's put in to our formula. Okay, mole. What is the subject we are looking for? Yes, sodium. And what was the formula? Yes, mass. You keep writing this until you can remember them by heart. Okay, that is recommendable. And because sodium is relative atomic mass, I'll just put in that. Okay, so the next step is just substitute. Okay, then you know that this is dividing. So what was it? So you take from the questions the mass 9.2 is put down there. Okay, 9.2 gram, a little bit space out will give some breathing space. Then AR. So the next thing you need to find is the relative atomic mass of sodium. Where do you find it? Yes, go to the periodic table. So let's go to that. Look for sodium, and you're familiar with sodium? Yes, that is. Let me zoom in. Alright, and which one is the relative atomic mass? The number below the symbol. Here we go, 23. So you take this number, go back to substitute that into your formula, and now let's go to press a calculator. 9.2 divide 23, and that gives you 9.2 divide 23, and nice and easy, it comes out for 0.4 mole, okay, of sodium. And the short form for mole is MOL. Okay, so it's fine, you just put in MOL, which also representing mole, which is its short form. Done. That's it. So this is how you get the numbers of mole from the given mass. Let's get more practice. Okay, why not? This time you pause the video and you may join me back to the solutions to this. Let's read the questions. Calculate the number of moles of 213 grams of chlorine. And the formula was given to you as well, Cl2. Okay, so let's go in and find. We know that the mass was given. Here we go. The next thing we need is to work out the molecular mass. Why do I say molecular mass? Because now, of course, this is Cl2. That means 2 pieces of chlorine. Okay, so now let us go there, and then so we're going to take molecular mass for chlorine. Alright, so now there are 2 pieces. Let's put in there 2 pieces. Okay, let's multiply 2 pieces of the Ar of chlorine. Okay, so you just go to find Ar of chlorine. Let's go back to the periodic table. Chlorine, again, zoom in for your easy view. Okay, chlorine, the number below the symbol will be the 1 atom of Ar. 1 atom, 1 mole of atom chlorine carries 35.5 grams. So let's take that, then put in to our formula. So that is 35.5. Okay, so that's put in. So multiply 35.5 times 2, and that gives you 71 gram. Okay, so now you got that MR and mass was given. Let's move to the mole formula. Again, practice mass in gram divided by MR. Okay, now substitute 213 gram divided by 71. Okay, if you want to put gram, it's fine because that's molar mass. And then, so 213 divided 71 will give you 3 mole. So that is the number of mole of chlorine in 213 gram. That's it. Okay, now let's move on to the third example. You may pause the video if you want to and join me later. Okay, so I shall move on. First, read the question. Calculate the number of moles of 1278 gram of aluminium nitrate. Okay, now of course it is super handy if you master how to write the chemical formula from their English name. Okay, but that is another that's the detailed explanation will be given in another time. Okay, but for this purpose the formula was given to you. Okay, so now the same thing, we know that we need to know the molecular mass. So let's take in the first step. Let's find the molecular mass for aluminium nitrate. Okay, and let's move on to the periodic table. Let's look out. Okay, why not you go there first? Okay, so aluminium, what is it? Okay, 27. Do we get the same number? Okay, aluminium, the number below that is 27. Nitrogen, what is it? Nitrogen, 14. Got it? Oxygen, what is it? 16. So we got all the numbers. Now we need to carefully put them according to the number of pieces of each of these element. Okay, so let's go there and put them together and sum it up. Aluminium, okay, aluminium, we know that it was 27 and it was one piece, so just one of them. And then we see the bracket with a subscript of 3, meaning there are 3 sets of NO3, 3 sets. So to make our calculation easy, I will just take 3 and then wrap it up with a bracket. Okay, and then I will just put in the NO3 inside. Now the AR for nitrogen, yes, we have seen that just now, 14. And plus, how many pieces of oxygen? 3. And we just put 3. Oxygen, we read from the periodic table was 16. Alright, so now just get our calculator to add up these numbers. So 27 plus 3 sets, okay, of 14 plus 3 pieces of 16 will be 48, and then, so let's get that. That is 213 gram. Okay, so you can put that gram as a molar mass. Okay, 213. If you do not put, it is not going to sacrifice any marks, but it is understood. Okay, so now in order to calculate the number of moles, all right, again bring up that moles formula. So it is super helpful to internalize formula. All right, so let's put in there. So numbers of moles of this will be what? Mass. Practice one more time. So we're going to write many times until you get internalize the information. So the mass, how much was it? 1278, and then divided by, how much was it? 213. all right, so I'm going to get the calculator. 1278 divide 213. What does that give us? That is 6 moles. Okay, 6 moles. All right, so that was 6 mole of aluminium nitrate. There you go. So here another successful case, right? So that is the basic skill for calculating mole from a given mass. Now the second skill that we need to make sure you acquire, okay, is to know the gas volume in room temperature and pressure, and usually it is short formed into RTP. Okay, in exam it will appear as RTP, but at times it may type for you the whole words, room temperature and pressure. And now I have put it down here. There's only one statement that all of us need to remember. At room temperature and pressure, the volume of 1 mole of any gas, okay, whatever that gas is, ammonia, oxygen, nitrogen, or sulfur dioxide, whatever gas, okay, each of 1 mole of any gas, they will occupy this much of volume, okay, they will occupy that much of volume. So that is, let's summarize this long sentence into, meaning 1 mole, okay, 1 mole of any gas, 1 mole of any gas, it will occupy, of course that equal means just representing, just to simplify that meaning, it occupies 24 dm cube of volume, or if you want to put in cm cube, of course you will just multiply 1000. Okay, so you're just going to get 24,000. Okay, just a little side notes, just for our information. Okay, so we know that 1 dm cube, 1 dm equals to 10 cm. All right, and so that 10 cm, that means 10 centimeter. So in the volume, if we cube up that, so that's why it is 10 to the power of 3, 10 cube of cm cube. This is how it comes about. Okay, so 1 dm cube is equals to 1000 cm cube. This is just a little side notes, just in case if any one of us are still not familiar with the conversion between dm and cm. Okay, so just a side notes. And now what essential for you to know is this magic number. You want to keep this in your memory. Okay, 1 mole of any gas, that's just what that, 1 mole of any gas, it will take up 24 dm cube or 24,000 cm cube. Okay, so just get this magic number nicely, comfortably in your permanent memory. Let's proceed to practice questions. Question 1. Calculate the volume of 0.6 moles of carbon dioxide at room temperature. Okay, so how do we move on to this? So super easy. From your memory, you already internalized that 1 mole of CO2 will surely occupy 24 dm cube. Alright, so now that they have 0 0.6 moles of CO2, how much would they occupy? What you need to do, just multiply 0.6 onto the 24 dm cube. Got it? And just punch the calculator. 0.6 times 24, what do you get? 14.4 dm cube. Okay, so if, just in case, if you want it to be cm cube, just easily, either you put in, let me just show you. Okay, so if this is in dm cube, let's say if you want to work this in cm cube, it is as easy as it is also. So just put in here. So I'll just put in all, yeah. So 0.6 times 24,000 cm cube. There you go. So you can take, so 0.6 times 24,000, then your calculator will show you 14,400 cm cube. Or you can do the conversion from here. Okay, you can do a conversion from here. You can just put it down, and then if you want to make that, so it's just 14.1 multiply 1000, that will make you into cm cube. So you will get 14,400 cm cube. Okay, whichever way, depending on what the question requested. If the question is requested in dm cube, you can provide and stop it there. But if they request to give the answers in cm cube, you can choose this method, or you can choose this method and then do the conversion at the end. Fine. Okay, you will get full marks for that. Okay, let's move on to the second questions. Calculate the volume of 0.2 moles of ammonia. Okay, why not? You pause the video and then join us later. Okay, so now I take it that you are ready to move on. So let's go on with the standard and the most precious information. 1 mole of ammonia. Remember, any gas, whether CO2 just now or ammonia now, it is anything is the same. Then let's say it is going to occupy 24 dm cube or 24,000 cm cube. Alright, so now you got 0.2 mole of ammonia. So let's also show you both. If you want in dm, so we're just going to 0.2 times 24 dm cube. There you go. Or you can just put 0.2 times 24,000, and this will be in cm cube. Is it clear? Alright, so now what you need to do is just a little punching some key in the calculator, and that you get 4.8 dm cube. And if you use this, you just go to your calculator, multiply by 24,000, and that magic number still appear, cm cube. So depending, read the questions, do they ask in dm cube or cm cube? Okay, now let's go on to practice number 3. Calculate the volume of 25.6 gram of oxygen. Okay, what is the difference that you see here? The two examples previously, the mole was given to you directly, and then in these questions you might get questions. Wait, where's the mole? How come you didn't give us the mole? Okay, here we go. Back to our first basic information or basic skill. We have learned that if they give us gram or mass, we have the skill or ability to convert that to mole. Yes, that is exactly what we're going to do. So we're going to use that previous knowledge now, and let's go to convert first. Okay, convert from mass to mole. Okay, so now we just go to find mole. Since they didn't give us direct, well, we can find it ourselves. Well, oxygen is O subscript 2, O2, and then so revise the formula again, mass in gram given to us, then divided by the MR. Okay, go to the mass. How much was it? 25.6 gram. Then divided by the MR. Okay, what was the MR? Oxygen. Just now we read from the periodic table. If you can't remember, no worry, just go back to the periodic table and you will see from there oxygen. One atom of oxygen is 16, and then there are 2 pieces now, so just put in 2 pieces of 16. Okay, so or if you want to, you can work out separately. Okay, the MR for oxygen, you can always work out separately. Let's just give you an example like this. Okay, you can work it out separately. MR for oxygen, you can work out separately 2 pieces of 16, and then that is 32. You can do that separately, and then only you slot in. Can, no problem. Okay, so now let's go and get the mole. Okay, 25.6 divided by 32, that gives us 0.8 mole. Now you have successfully convert gram into mole. Okay, now we move on to answer the questions now. Calculate the volume. Alright, so now we go to answer that. Let me move this one in. I'm a little bit running out of space. Okay, now just to revise again, what is the volume for 1 mole of gas? Oh, sorry, let me keep it zoomed so that we can make it clear. Alright, so here we go. Just for practice again, 1 mole of oxygen or any gas, it will occupy 24 dm³. Due to the lacking of space, I'm just going to demonstrate dm³. So now we got 0.8 mole of oxygen. Yes, I can hear you say that. 0.8 multiply 24. And let's go that times 24, and there you go, 19.2 dm³. That's it. Okay, so these are the revisions of our lessons. Okay, or rather ensuring all of us acquire both of this background information and skill. 1, able to calculate mole from mass, and then able to convert from mole into the gas volume it occupies. Okay, now with that, let's go to the last part of this video. I have snapshot a part of the questions from a past year paper. Okay, so now a petrol car makes 236 grams of carbon monoxide gas when 1 kilogram of petrol is burnt. Calculate the volume occupied by 236 grams of carbon monoxide gas. The molar gas volume at room temperature and pressure is 24 dm³. They were so generous and they were so kind by providing that. Okay, so if they provide, it is super generous. If they didn't, you already memorized that magic number 24. Okay, so now if you look at the marks, it is 3 marks allocated. Surely it is not a one-step thing. So let's move in. Okay, we know eventually in order to find that gas volume, okay, let's split that into 2 stages. Okay, the volume for the carbon monoxide, okay, we of course need to know what is the chemical formula for carbon monoxide. Okay, I hope all of us already know that carbon monoxide is C for carbon, and mono meaning 1 oxygen, so CO. However, if you are not sure about that, you can refer to another video that we're going to talk about that. Okay, so now CO, alright, C and O. So now what we're going to do, let's find what is the molar mass for CO. Oh, why was it? Okay, just now I haven't finished. We want to find the molar mass, the volume of CO. It requires us to put in the mole of CO, and then we know that we're going to multiply that magic number 24 dm cube. Okay, for this case they request in dm cube, so it's fine to just use dm cube. And then, so you know that you don't have this, so you're going to get from some kind of preparation here to find the mole. So now let's go on to find the molar mass for CO. Let's go to the periodic table. Where's the periodic table? Let me just go there. Okay, if you're not yet familiar, okay, let's go to carbon. We know that it is 12. Oxygen, it is 16. Then let us go to our questions there. Okay, here we go. So carbon, let's put in 12. And one piece of oxygen, just put in 16. So that is 28. And using this information, let's go to find numbers of mole in this carbon monoxide. Revise for all of us again the formula: mass in gram divided by the mR. So in this case, it is the mass 236 gram divided by 28. So this is the mole of carbon monoxide. Okay, so now what we do, you were just going to take this and substitute that in that place. Okay, so let's take that 23. Okay, all right, so I don't want to copy and paste, I will just write that 23 over 6, 28. Okay, of course if you want to punch that into a number, no problem. 236 divide 28. Just make sure you do not round up too much. Yeah, so let's put that as 8.43. okay, just put that at 8.43 or 8.4386 is fine. Okay, so you can put it that way, or you can just keep it as the division, the whole thing there should be no problem. And then now you multiply 24. Okay, so now we just go to multiply 24, and then we get 202.3. Yep, that is the dm cube, and then of course that is dm cube here. Alright, so you can put in that 202, or you can put in 202.3. Alright, so you can put in that as your final answer. Alright, 202.3, or just simply put 202. It is acceptable also because it is 3 significant figure. You can also put in here 202. Alright, so that is the assurance. Okay, mastering the 2 pieces of the basic information, and that will surely leads you to that full 3 marks of answering questions of this category. Okay, let's revise the information. First, the conversion of mass in gram to mole. What is it? Yes, mass divided by their relative molecular mass, AR or MR. Number 2, 1 mole of any gas occupied 24 dm cube of volume, or 24,000 volume. Okay, if you're still not clear, you may rewind and watch the video again, and I can assure you, in no time you will be the master in this area. Okay, congratulations, and that's all for today, and then please take care. I'll see you in the next video. Bye bye.